So for the table, you should see a little pattern here. Whenever y is -2, the slope is -4. When y is -1, slope is -2. Y is 0, slope is 0. Y is 1, slope is 2. Y is 2, slope is 4. So we get that pattern, -4, -2, 0, 2, 4, and so on. And when we graph it, it should look like this. It's a little different than our last slope field. For this one, if we look at, let's say we dropped something here, or this was our starting point, but like I kind of talked about before, if we dropped a leaf in the water here, the flow of the water is pushing it this way, and then it kind of flattens out. Down here, if we drop a leaf over here, it's flowing this way and then flattens out. And so there's a little difference depending on where the point goes. The other one, it was always a parabola, same shape, just kind of shifted up or down. This is a little bit different. Let's go ahead and take a look at the last part. The last part asks us again to find that particular solution, y equals f of x, so we have to solve for y, to the given differential equation with the initial condition 0, 1. So this time dy dx equals 2y. So to solve this differential equation, we need to get the dy and dx separated. So I'm going to multiply both sides by dx. But then we want the y on the side with the dy, not over here with the dx. So we're going to have to divide both sides by y. We get 1 over y dy equals 2 dx. So we've separated the variables here. We have the y on the side with the dy. There are no x's, but this 2 can just stay here with the 2x. Now we can take the antiderivative of each side. What's the antiderivative of 1 over y? Natural log of absolute value of y. And then antiderivative of 2 dx, 2x, and then we need to remember the plus c on the right side. We don't need it on the left side. We just need it on one of the two sides. So we've got our equation with c in it, but we want to figure out what c is. That's where our initial condition comes in. We're going to substitute 0 in for x, 1 in for y. So we end up with natural log of absolute value of 1, which is just 1, equals 2 times 0 plus c. So this is just going to be 0. What's the natural log of 1? E to what power gives us 1? 0. Natural log of 1 is just 0. So c just comes out to be 0. So we end up with natural log of absolute value of y equals just 2x, because c came out to be 0 in this case. But we're not done. It asks us to solve the particular equation y equals f of x. That means we have to solve it for y. So to solve it for y, we need to get rid of this natural log. What do we do to both sides in order to get rid of that natural log? E, right? We're going to do e to this power equals e to this power. So e to the natural log, those are inverses. They cancel each other out. We're just going to end up with absolute value of y equals e to the 2x. So we're a step closer, but we're still not quite there. We need it to be y equals, not absolute value of y equals. So one last step to kind of figure out. So I'm going to, off to the side here, just go back to some algebra, basic algebra. If absolute value of x equals 9, what could x equal? Positive 9 or negative 9, right? It could be one or the other. So we have to keep that in mind with this. Absolute value of y equals e to the 2x, then either y equals e to the 2x or y equals negative e to the 2x. So we have a choice to make. Which one is it? It has to be one of these two, and it's not a guessing game. We can figure out which one it is from this initial condition again. Right? This has to work in the equation. It's only going to work in one of them. So if we take this and plug it in, if we put 0 in for x, e to the 0 is just 1. That works out, right? Just check this one just to make sure. If we put 0 in for x here, we get e to the 0 is 1, but there's a negative out in front of it, so y would have to be negative 1. But here, clearly it says the y value is 1. So this one does not work, and this is our answer for this one.